All right, here we go, everybody. Math 1200, week 9, lesson number 2. Let's just continue along the lines of our study of geometry. Our next session, I think we're going to get into some similar figures, and that'll lead us into a study of trigonometry. But for now, we're just going to extend the concept of parallel lines cut by a transversal, and of course we're going to review a bunch and so on and so forth. Here is our agenda for today. Homework answers, got to go over those, the do it. And just a brief word about homework answers. It's not enough to do the homework. You've really got to focus on the answers, see if you've gotten them right, and then learn what you didn't get right. The do it, and then as always, some recent review work, and then we're going to apply parallel line concepts to triangles and do some isosceles triangle problems and so on. Not too many word problems, more diagrams. Okay, here's the first part of the homework answers. Sorry about the puppies barking inside. You're on stop and start anyway. Here's the second part of the homework answers. And today's do it. Okay, so the ages today, Callie is 3 years older than Katie, so it's x and x plus 3. And then in 5 years, well, then it's x plus 8 because you're adding 5 to Callie. 3 and 5 make 8. And Katie's x plus 5. And then it says the product of their ages of Callie and Katie today is 130 less than the product in 5 years. So you got to do today, x times x plus 3 is going to equal the one in 5 years, x plus 5 times x plus 8 minus 130. So product of the ages today is x times x plus 3, and in 5 years it'll be x plus 5 times x plus 8, and then you've got to subtract 130 from that. So let's do a little algebra here. X times x plus 3 is x squared plus 3x. X plus 5 times x plus 8 is x squared plus 8x plus 5x plus 40, and then of course minus 130. That's x squared plus 3x is x squared plus 13x, getting the 8x and 5x together, minus 90. That's the 40 and negative 130 together. Ooh, look at this. We can subtract x squared from both sides, and we get 3x equals 13x minus 90. Subtracting the 13x, and I get negative 10x is negative 90. Danger, danger, danger there. Make sure you're peeking in front of that 90 to remember it is negative. That 13 is positive, so I have to subtract 13x from both sides, and 3x minus 13x is negative 10x. I divide and I get x is 9. So what does that mean? That means Katie is 9 today, and Callie is 12. Okay. Praxis power. Performance is a function of preparation. What we're trying to do here is take the concepts of thinking mathematically, even though we didn't necessarily study each and every one of these questions, and apply them to these questions. Give this a shot. Okay, so this is a little proportional reasoning, and over the course of the next couple of weeks, we're going to get into this a lot more. In fact, next lesson, we're going to really start hitting this a lot with similar figures. So proportional reasoning basically says something like this. Look, most kids have at some point in their life, they've either babysat or cut a lawn. So let's just go with babysitting. If you went and you babysat some neighbor's kid, and you worked for 2 hours, and you made, let's say, $25. Then, if you babysit for 4 hours, how much should you make? And by proportional reasoning, it would be $50. setting it up in a proportion for this particular problem where they're talking about aquariums, and one of them's 20 gallons, one of them's 50 gallons. She adds 3 tablespoons of salt to the old or 20-gallon aquarium. If she wishes to maintain the same salinity level, how many tablespoons should she add to the new aquarium? Well, salt is to gallons as salt is to gallons. That's your proportion. A proportion is an equality between two ratios or two fractions. So 3 tablespoons of salt for 20 gallons is how many tablespoons of salt for 50 gallons. And then we're going to do something that we did years ago, which would be called cross multiply. Technically, it's the product of the means equals the product of the extremes. I'm going to multiply these two guys, 20 times n, and these two guys, 3 times 50. So 20 times n is 150, dividing by 20, n is 7.5. So you'll need 7.5 tablespoons of salt. So once again, when you cross multiply, you multiply across the equal sign. 20 times n was 20n, and 3 times 50 was 150. And then I just solved the equation that results. Choice A. All right, this one we worked on last week at this time, or the other day at this time. Let's have you try this one, but I changed it to the box containing 50 widgets in 10 minutes. Go ahead. Hey, guys. Okay, so there are 60 minutes in an hour and 120 minutes in 2 hours. This problem is expressed in terms of 10-minute blocks. So if I divide 120 minutes by 10 minutes, I get 12 of these blocks of 10 minutes long each. And each one of these blocks makes 50 widgets. So 12 times 50 is 600 widgets is what would be made. Factor 3x squared minus 2x minus 5. Go ahead. Okay, so I look for a greatest common factor. There is none, which means I go to what we call plan B, which means I'm going to take the lead coefficient of 3, multiply it by the last term of 5. That gives me x squared minus 2x minus 15. Factor that. X minus 5x plus 3. But since I changed this question by multiplying the last term by the lead coefficient, which was 3, I now need to divide that coefficient back into the last term. So I divide each of them by 3. And then I can reduce 3 over 3. That's 1. And then I do the common denominator elementary school trick, whatever you want to call it. And I make the first binomial 3x minus 5 by putting that 3 in front. So it's 3x minus 5 times x plus 1. Now let's multiply back to check ourselves, of course. 3x times x is 3x squared. 3x times 1 is 3x. Negative 5 times x is negative 5x. 3x and negative 5x make negative 2x. Ding, ding, ding. That's what I was looking for. And negative 5 times 1 is negative 5. Okay. Little do it for today. Reduce this rational expression. Go ahead. Okay, so factor and cancel, factor and cancel. All that you do is you factor and cancel. So I factor the numerator, and I get x plus 3 times x plus 2. I factor the denominator, x plus 12 times x plus 2. The x plus 2's cancel, leaving me with x plus 3 over x plus 12. Of course, there's mathematical matrimony going on here, and I cannot reduce the 3 and the 12. Just the x plus 2's, because x plus 2 over x plus 2 is indeed 1. All right, let's try these two questions. Go ahead. Okay, first question. I always need a common denominator. In order to find my common denominator, which is like the common category that allows you to unite these terms. So what we're looking to do here is get that common denominator, which would be, sorry, that's my son, Ziva, stop howling. That's my son calling. My wife will have to talk to him. 3x plus 5 over x minus 4 times x minus 3. That's the factoring of x squared minus 7x plus 12. And then 3 over x minus 3. Well, the one on the left has what the one on the right has, so I don't need anything on the left, but I do need an x minus 4 on the right. So my common denominator is x minus 4 times x minus 3. My numerators are set. Let's distribute the negative 3. That gives me negative 3x plus 12. And now, because you distributed that negative sign, you're now adding. So 3x and negative 3x adds up to 0. And then 5 and 12 add up to 17. So I get 17 over that common denominator of x minus 4 times x minus 3. Okay, some people might say, oh, you're supposed to add them. No, whenever you add or subtract, you have whatever your type of thing is, and it stays the same. If it was puppy dogs and puppy dogs, I would get puppy dogs. And in this case, it's x minus 4s times x minus 3s, which is a little weirder than puppy dogs, but it still is what it is. And like puppy dogs, it must stay the same. Okay, on number 2, I factor, and I get y minus 6, times y plus 1 here for the first one. For the second one, I get y minus 5 times y plus 1. So I noticed that both denominators have a y plus 1, but the one on the left needs the y minus 5 from the denominator on the right, and the one on the right needs the y minus 6 from the denominator on the left. That gives me, when I distribute the y here, y squared minus 5y. And when I distribute the negative 7, I get negative 7y plus 42, and then I add. Putting it together, I get y squared minus 12y plus 42 over the y minus 5, the y minus 6, and the y plus 1. I try to factor y squared minus 12y plus 42. No can do. Therefore, I am done. I've gone as far as I can go. As always, if these give you difficulty, and I would consider these pretty challenging, not super hard, but reasonably difficult, I would go back and do them again and make sure I got them right this time. If there's any other issues, excuse me, make sure you speak to me about it. Systems of linear equations. So we're going to go back and remind you, when do you use elimination? When do you use substitution? You use elimination whenever you see the things lined up, like x's over x's, y's over y's, equals over equals, numbers over numbers. You use substitution when things are not aligned. The x's are over the y's, the equals are not near each other, etc. So those are your cues to figure out when you're going to do them. Also, if one of them says, for argument's sake, a equals whatever, and then on the next line, a equals whatever, it's substitution. You just make them equal to each other. Okay, we're not doing a linear system this time because we've done a lot of linear systems, but we are going to do a quadratic linear system. Give it a shot. Okay, so since the y is equal to the x squared minus 5x minus 2 and the y is equal to the negative x plus 3, they must be equal to each other. So I get, by substitution, x squared minus 5x minus 2 is equal to negative x plus 3. Add the x, subtract the 3 to both sides. I get x squared minus 4x minus 5 equals 0, almost like the last time we did one of these, but the signs are reversed. That makes it an x plus 1 times x minus 5 with the factoring, right? Two numbers multiply out to negative 5, add up to negative 4 equals 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Solving for the first one, x is negative 1. Solving for the second, x is 5. So I can go back and get y using either equation. It's just so much easier to use the bottom one. I don't have to worry about exponents and so on. Y is negative x plus 3. The negative of negative 1 is 1. Plus 3 makes 4. And then the negative of 5 plus 3 makes negative 2. So negative 1, oh, I should say negative 1, 4, sorry. And negative 5, negative 2. All right, a little review about angles here. We'll start off with just numbers. No algebra yet. So let's start with finding A, B, C, D, E, G, and H. F is the 120. So given the 120, find the others. Go ahead. Okay. So all of the acutes are equal to each other, and all of the obtuses are equal to each other. Now, angle A is obtuse, as is C and H, so they're all going to be 120. How do we find the measure of, say, either B or E? Well, together, they make up a straight line. It's one acute and one obtuse, so they have to add up to 180, which makes them 60. So A was 120, C was 120, H was 120. B was 60, which makes E 60, which makes D 60 and G 60. And just keep in mind that every single acute angle in this diagram is equal. Every single obtuse angle is equal. And one acute and one obtuse add up to 180 degrees. All right, so now we're going to apply some algebra to these situations. Let's see what you get here. Determine if you think these two angles are congruent or if you think they add up to 180 and solve. Okay, so I hope you see that they are alternate exterior angles, which we know are congruent, or they're both acute, which, oh, I'm sorry. Yeah, they're both acute, which makes them congruent. And if you did drag and drop, they would end up being vertical, which makes them congruent. So 4x plus 16 is going to equal 7x minus 20. Let's get the letters on one side, numbers on the other. Subtract 4x from both sides. I get 16 is 3x minus 20. Add the 20. 3x is 36. X is 12. Okay. X works out to be 12. We could substitute it in. 7 times 12 is 84. Minus 20 is 64. 4 times 12 is 48. Plus 16 is 64. Let's try the next one. Go ahead. As always, the first thing you do is determine if you think they're equal or if you think they're supplementary, and then set up your equation and solve. Really breaks down to, is it a same side or opposite side situation? Okay, so looking at these, one is acute and one is obtuse. That makes them add up to 180 degrees. So 4x plus 19 plus the 3x is 180. 7x plus 19 is 180. 7x is 161. Dividing, and I get x is 23. Okay. All right, let's try this one. Give it a shot. So it works out on this one that we have alternate interior angles, or they are both obtuse. So 3x plus 16 will equal 5x minus 54. Letters on one side, numbers on the other. I subtract 3x from both sides. 16 is 2x minus 54. Add 54 to both sides. 2x is 70. Dividing by 2, x is equal to 35. Okay? All right. Next up, let's see what you get. Okay. Now, let's see what we get. These are alternate interior angles, or they're both acute, so they're going to be equal. So 4x plus 2 will equal 3x minus 2, subtracting the 3x, subtracting the 2, and I get x is negative 4. Now, I know in reality, you couldn't have a negative angle, but this is how they set the problem up. So just carrying it through, that's what we get. All right, let's find the value of x in this diagram where lines M and N are parallel and the purple line is the transversal. So, in this case, one angle is acute and one angle is obtuse, or you can think of it as if we did drag and drop, they would land next to each other, add up to a straight line, which would be 180 degrees. Same sides, same operation. 8x plus 3x is 11x. Negative 3 and negative 4 is negative 7. 11x minus 7 is 180. Add 7 to both sides. 11x is 187. Dividing. X is 17. All right. So now you're going to have to find x, and you're going to have to also find y. Go ahead. Kind of like two problems in one here. I noticed that my x's are both going to be obtuse and they are alternate interior angles. So therefore, 17x minus 70 will equal the 2x plus 5. Subtracting 2x, 15x minus 70, adding the 70, 15x is 75, dividing, and I get x is 5. Now I can focus on my y's, and my y's are consecutive interior angles, so I know that they have to add up to 180. Also, one is acute and one is obtuse, and if we did drag and drop, they'd land next to each other. So they add up to 180, so 3y plus 5 plus 5y plus 15 is equal to 180 degrees. Same side, same operation. 3y and 5y make 8y, 5 and 15 make 20. Subtracting 20, 8y is 160, dividing, y is 20. Okay, so that reviews all of the work done last week and in previous lessons. Now I want to just get into the new stuff for today, which, you know, you've seen a lot of before, but I do want to review this material and these concepts for what you might see in other classes. For instance, one of the courses that I teach for the school is MTH 1250, and this is MTH 1200. So 1250 would be an extension of 1200, and what we try to do in 1250 is all geometry. So you would take some of the lessons in this course and apply it to that course, and that course would then build on what we cover in this particular class. Now, and again, we're trying very hard to get you to see relationships and concepts, mathematical concepts in here. We've focused most of our efforts on relationships involving algebra and algebraic concepts like combining things that are alike, not when you don't, laws of exponents, etc. What we're going to talk about here is now a little more concrete, and it's dealing with geometric structure. So for instance, let's say I start with triangle ABC, and I want to prove beyond a shadow of a doubt that the three angles of a triangle add up to 180. And then I can apply that in future problems, and I can look for those relationships. And it involves understanding our parallel lines cut by, in this case, two transversals. So what I notice here is I'm going to draw this line X through the point A so that it's parallel to BC. And then my two red angles are alternate interior angles, and my two blue angles are alternate interior angles, just in different locations. So what I notice when I look at this is up top, this half circle here, that adds up to 180 degrees because it's all three angles make up a straight line. Now, if these two blue angles are the same and these two red angles are the same, substituting red for red and blue for blue, then what I can see is that likewise, since one red, one yellow, and one blue at the top add up to 180, one yellow, one red, and one blue also have to add up to 180 in the triangle. So that proves that the three angles of a triangle have to equal 180 degrees. Okay? Three angles of a triangle must equal 180. And then we could also look at it here. If we had angles A, B, and C, and we know in the red circle there that they have to add up to 180, but by alternate interior angles, this angle down here in the bottom right corner, that's also angle B. They have to be equal. And down in the lower left corner is angle A. So if A plus B plus C is 180 up at the top of the triangle, then A plus B plus C has to add up to 180 in this triangle as well. So those are two ways of looking. It's the same way of looking at it, just two different diagrams. Okay, so in the first diagram, let's see you find the value of the question mark. Pretty easy question, I think. So first I got to add up the 55 and the 82. That is 137 degrees. Subtract it from 180 and I get 43. Now let's try the next one. See what you get for the question mark there. Again, first I add up this symbol here. This is a right angle symbol. That means 90 degrees, okay? The 90 plus the 52 is going to add up to 142. 180 minus 142 is 38. Okay, so we did some with basic arithmetic. Now we're going to, bam, as Emerald would say, kick it up a notch, bam! Find the value of x. And what you know here is that these three angles must add up to 180 degrees because they're the three angles of a triangle. Go ahead. Okay. Now, add up all the x's. I'll add up all three angles and then combine like terms. So I'm going to get my x's, which is going to be 14 x's, and my numbers together, -1, 4, and 9 is 12, sorry. And 14x plus 12 then has to equal 180 because all three angles of a triangle have to add up to 180 degrees. Subtracting 12, 14x is 168, dividing by 14, I get x is equal to 12. All right. Now, the next type of triangle we get, it's on the right-hand side of this slide, is an isosceles triangle. And how do I define an isosceles triangle? An isosceles triangle is a triangle with two sides equal, x and x. But it's also a triangle where its base angles are equal. And the base angles are the angles that are across from what we call the legs of the isosceles triangle. So the two x's, they cover the equal legs. And then if we go with the angles that are across from those legs, those are called the base angles. So the two base angles are always equal. The two legs are always equal. That's the x and the x. And that one lonesome angle up at the top that doesn't have anything that it's equal to necessarily, that is the vertex angle. Okay, so vertex angle up at top, the legs are on the side, and then the at the bottom is going to be our base angles, base, bottom, etc. So now we take a look at the diagram on the left. What are the two equal legs in that diagram? Well, that would be AB and AC, okay? What would be the base angles of this diagram? Angle B and angle C. Now, the last thing is what's the vertex angle? And that's the blue angle up at the top, angle A. Now, this is a little quick proof of why the sides of an isosceles, or given that the sides of an isosceles triangle are congruent, why does the triangle why do the pieces have to be equal? And So it's isosceles, so you know the legs are equal, right? And then you know that you're going to have the median, which is point D, the middle of B and C. So that means that AD, the line running right down the middle, that is going to be congruent to itself by a reflexive. We know that these are right angles. So in short, the two yellow triangles have to be equal, which means that all the parts have to be equal. That's why the legs of an isosceles triangle are congruent to each other and the base angles are congruent to each other. So find x and y in this diagram. So first, you notice that the two legs are each 7 feet, so the angles across from those legs have to be equal. So the x has got to equal the leg across from the 7 feet, and or the two base angles across from the 7 feet, and that means that the 50 also has to be x, or x has to be 50. And then together, the 50 and the 50 add up to 100, and that means y has to be 80. I made a mistake on this before. Look at that. This should be 100. A little off my game today, sorry. And that would be 80 degrees. So angle y has to be 80. 50 and 50 at the bottom add up to 100, and then the 80 for y is 180. Okay. All right, so now we got a little mix of x's and y's here. Now, the congruent triangles, or the congruent angles, are this one at the bottom here, the 72, and then the one up top here, which says 8y minus 16. Give that a try and see how you do on those. Then after you get that, you can go back and figure out what x has to equal. Okay, so we know the 8y minus 16 has to equal 72. Adding 16, dividing by 8, y is 11. So now, the angle at the top and the angle at the bottom are both 72. 72 times 2 is 144. If I do 180 minus 144, I get 36. So this one angle at the side here, which is the vertex angle, that has to be 36 degrees. So therefore, 9x is 36 and x is 4. Okay? All right. Give it a shot. Find x and y in this diagram. Okay, so it's an isosceles triangle because of these two little marks here. That says the legs are equal. The angles across from those legs are going to be equal too. So y will be 52. We can do that right away. Very quick and easy. Now, if 52 and 52 adds up to 104, that means that your vertex angle at the top has to be 180 minus 104, and that is 76. But they say it's 14x plus 6. So 14x plus 6 has to equal 76. Subtracting the 6 and then dividing the 70 by 14, x is 5. Okay? All right. The happy recap. What do the three angles of a triangle have to add up to? 180 degrees. How do parallel lines help prove this? Well, this is the diagram with the red, the blue, and the yellow add up to 180 because they make a straight line. And then by alternate interior angles, one of the reds and one of the blues go inside the triangle. So likewise, by a little substitution there, the three angles of a triangle have to add up to 180. What's an isosceles triangle? What makes it special? Two sides are equal, two legs are equal. And if the two legs are equal, then the angles opposite them, or the base angles, are going to be equal as well. So what parts are congruent? The legs are congruent to each other. The base angles are congruent to each other. There is a type of triangle, a special type of equilateral triangle called special type of equilateral of isosceles triangle called an equilateral triangle. That's when all three sides are equal. But isosceles, you only need two to be isosceles. Have an awesome day, guys. Take care.